Recording in progress.
Hi guys, good afternoon. So let's continue with our part from the network components, and we were talking about the cables. Okay. So how many types of cables? Many. What are those? Okay, then inlet and so coaxial cable, fiber optical cable, USB cable. Then you will say charging cable, data cable. See, major two categories. Okay, major two categories. What are those? Copper and fiber. Major two categories. Then in your copper, you have further two categories. One is twisted pair, and second one is coaxial. Then twisted pair further into two categories, shielded and unshielded. So in short, I'll call it UTP, and this one STP. Then in UTP, we have different categories. In the UTP cables, we have different categories. So what are those categories? One, two, three, four, five, 5E, 6, 7, 8, like that it will keep on going. Now, what is the difference in these categories? The difference is speed. The difference is speed. Like Cat 1, 1 Mbps, 4 Mbps, then we have 10 Mbps, 16 Mbps, 100 Mbps, 1 Gbps, again 1 Gbps, then we have 10 Gbps, and then we have 40 Gbps. Like this, we have the Ethernet cable. And same sort of categories you will find in, your STP also. Okay. Then your coaxial cables. These are the cables on which your initial networks, starting networks were designed. How do your coaxial cable looks like? Like your dish TV, DTH cables you might have seen. There is one wire at the center, and with that wire we start communication. We have communication. That is coming from the dish TV antenna to your receiver. Okay. So those cables, those are what? Your coaxial cables. Twisted pair, these are the cables which are having 8 wires. There will be 8 wires in these cables. And pair means what? A group of 2. So that means total how many pairs will be there? 4 pairs. Okay, what are those pairs? So we have orange pair, we have green pair, we have blue pair, we have brown pair. These are the 4 pairs available. Okay. How do your twisted pair cable looks like and why their name is twisted pair? Let's understand. This is how a twisted pair cable looks like. So four pairs are there. You see here, this one is blue, this one is orange, this one is green, and this one is brown. Okay, these are the four pairs. In each pair, two wires will be there. So one wire will have complete color like this, blue color wire, and another one is going to have a white. Okay, some part of white it is going to have. So like these two wires, we'll call them, this one is blue, and this one we'll call it white blue. Okay, we'll call it white blue. Okay, like this. That it has some part of white, some part of blue. Same way, orange, orange, green, white, green, and white, brown. This is clear. This is your twisted pair cable. Your coaxial cable. Okay, this is a real coaxial cable. You can see. Okay, so at the center there will be one wire. Okay, through which your data will be transmitted. This is your coaxial cable. Now, if we talk about fiber cables, how many types of fiber? You didn't check? Fiber two types, single mode and multi-mode. These are the two types, single mode and multi-mode. Your single mode cable is able to transmit information to large distance. Okay, so these are used for large distance transmission. These are used for large distance transmission. And these are used for smaller distance. Okay, so whenever you want to have large distance transmission, you will be using what? Single mode. And if small distance transmission, you can go with the multi-mode. Other difference, in single mode, only one signal will be traveling. In single mode cable, only one signal will be traveling, while in your multi-mode cable, multiple signals will be traveling at the same time. Okay. So if you want to see how they look like, single mode and multi-mode. So you can check this diagram. This is single mode. Only one signal is traveling. And in multi-mode, you can see multiple signals will be traveling. Okay. So in your single mode, your laser signal will be traveling. And here, light signal will be traveling. So like, bulb in home, how far it can, like how far the light from the bulb can travel? Not really far, right? If you put a bulb outside in the dark, so it will not give you light for a long distance. After some point, it will start getting darker. But what about a laser signal? We have played in our childhood, right? With the lasers, how far it can travel, right? It will keep on traveling. So compared to your light signal, your laser signal will travel farther distances. Okay. So that is the thing that single mode, one signal, and that is the laser signal. That means highly focused signal. Okay. So it will travel till the large distance. And these signals, these are what? Signals which are reflection, like reflection, refraction. So many processes are happening here. Okay. So they will travel only for shorter distances. This is clear. And the core also, the core of your multi-mode fiber will be larger than your single mode. That means what? See, this core is made up of glass. This core is made up of glass. So here you can see like it is 9 micrometer, the core is, and here it is 62.5 micrometer. So that will be comparatively large because it has to accommodate more number of signals. That is why. Is that clear? Okay. Now, in networking, we use two types of cables, straight through and crossover. Okay. So again, right now we don't have the concept of crossover cables. Right now, only one type of cable is used, that is your straight. Right now, crossover concept is not there. We don't use that. Okay. So straight through cables, these are used to connect different types of devices. Like if I want to connect a router to a switch to a PC, then I will be using which cable? Straight through cable. And if you are connecting same type of devices, in that case, earlier you needed what? Crossover cable. But now we do not need it. Now even same type of device, you can use straight through cable and it will be working very fine. Okay, because these days devices are getting more smart. Earlier we didn't have this kind of concept. Okay, so earlier the devices were not very smart enough, so we needed to use what? Crossover cable. So what was happening that time? Why this kind of concept was there? That same type of devices we use crossover, different type of devices we use straight. So understand. First of all, let's talk about straight through. Okay. Now straight through cable, you say that okay, you use it to connect different type of devices. Used to connect different type of devices. So let's consider you have one cable. You have one cable. And on both the ends of this cable, we will have two connectors. Yes or no? We will have two connectors. And these connectors of these cables, they will be connected into your devices, whether it is a switch or a router, you will connect it into devices. Consider this is a router, and this side I'll be using a switch. Different type device. So in the router and switch, there is an arrangement of pins. Okay, they will decide that okay, this is pin number on which I will accept the information, and these are the pins on which I will be transmitting the information. So since in the Ethernet we are using twisted pair cables, that means how many wires will be there? 8 wires. So that means in this connector, how many pins will be there? 8 pins. What is this connector? RJ45. Same way this side also RJ45. Okay, so how does it look like? This is how it looks like. Okay, so you can count the number of pins. 1, 2, 3, 4, 5, 6, 7, and 8. 8 pins will be there. So if here we have 8 pins, that means in the device where you will be connecting this connector, that is also going to have how many pins? 8 pins, right? Okay. So now what? In this router, we will again have connector, and in the connector, 8 pins will be there. So let's design the arrangement of those pins. So let's say this is the connector of router. This is the connector of router, and this side, it is the connector of switch. So in router, how many pins will be there? 8. 8 pins. Okay. And same sort of 8 pins will be there here also. Now in router, this thing is fixed that, okay, router will use what? Pin number 1 for transmitting the information, pin number 2 also for transmitting the information, pin number 3 it will use for receiving the information, and pin number 6 also it will use for receiving the information. Okay, this is fixed. And in the switch, it is reverse. Switch will say, I'll use pin number 1 for receiving the information, pin number 2 for receiving the information, pin number 3 for transmitting the information, and pin number 6 also for transmitting the information. Okay, here you can understand the full duplex concept also. This is clear? Okay. Now what? If router has to send some information, switch has to receive. And if switch will send some information, router has to receive. So I want that the transmitting pin of router should end up where? At the receiving pins of switch. So that means, can I simply say that, okay, I need to connect the pin number 1 from the router to pin number 1 on the switch, and pin number 2 from the router to pin number 2 of the switch. So what will happen? Automatically the data will, router will transmit and it will end up where? In the receiving pins. Then pin number 3, you see, switch will transmit, router will receive. Same thing. Switch will transmit, router will receive. So communication will happen without any issues. Okay, and we didn't need to change only pin, whatever the wire you connect on connector number 1, on the other side also pin number 1 you connect the same wire. So that means same pins are connecting same wires. So this is straight through. That means completely straight cable. Okay, no interchanges of the pins. This is completely straight cable. Okay. Now, what if this is also a router? Let's consider that case. Straight through cable concept is clear. Now let's come to the crossover cable. Now this time I'm considering this is also what? A router, same type of device. And these wires. Now if both are the same devices, that means the pin arrangement will also be same. This will be the pin arrangement. Now, if I use a straight through cable, why these devices will not communicate? Because straight through cable will connect my pin number 1 to pin number 1. So if a router will transmit some information, that will end up where? On the transmitting pins of the other router, and router will not receive this information. Okay. So what do we need? That when router 1 will transmit, router 2 should receive. So that means my pin number 1 should connect where? Pin number 2 should connect where? Pin number 3. Let me change the color. And pin number 6. Do you see? These are crossing. This is crossover. Is it clear? So why same type of devices they require crossover, and why different type of devices will require straight through? Okay. So you will say about crossover. Used to connect same type of devices. Okay. Now in your router and in your PC, this arrangement is same. So router and PC will also be considered as the same type of device, and you have to use what? Crossover. Okay. Now, like I said, right now we don't require any sort of crossover cable, because right now devices can automatically adjust between transmission and receiving. Okay, they can automatically adjust between the transmitting and receiving pins. So we don't need to use this. We can use a straight through cable and it will totally work fine. But if you come across older series of routers, then you will get stuck. So that is where you need to know this concept. Is that clear? Because if you connect straight through cable in the older series, your ports will never come up. Your ports will never come up. Okay, they will always remain down. Router ports, they will always remain down. That means there will be no communication at all. Clear? So about the cables, this thing is clear. Now let's move on to the next thing. Straight through crossover serial cable. So the serial cable we used to use in the older times, but they had a speed limitation like 4 Mbps. But now we need speeds much faster than this. So we don't use again. Okay. Otherwise, these also they used to connect router to router. The serial cables they used to connect router with a router. Console cable. So which one? This is RJ45 to RJ45. Tomorrow I'll show you. Okay. Console cable is a type of cable that is used to take physical access of a device. When you purchase a new device, whenever you purchase a new device, in the device, there will be no configuration because it is a fresh device. So there is no configuration. So to do the initial configuration, you have to access the device. Okay. So how will you access it? Using the console cable. How does your console cable looks like? This is how your console cable looks like. So in this cable, you will have two ports. One will be your RJ45, second one will be RS232. Okay. This is your RJ45 connector, and this one is RS230, or you also call it as a serial connector. Don't confuse it with VGA. VGA is different, serial is different. VGA will have 15 pins, and serial will have only 9 pins. Okay. So this RJ45 connector, this will connect into your device. Okay, like your router or switch, whatever it is. So this is where you will connect it in your device. And this you will connect it into your PC or laptop, whatever you're using. Now you might say that, okay, what if this port is not available? PC is fine, but in laptop it is not available. Okay, so what you will do? We will convert it. At least USB is available. So we will convert it into USB. How? We are going to use converters. So I'll say what? I'll use a serial to USB converter. These kind of converters you will be using. And these converters, what they will do? They will give you a USB interface. And this USB you will connect where into your PC. Then after you will be able to take access of the device, you can do the initial configuration. And after that, you don't require your console cable. One time configuration done, later on you can directly access using IP address and you can do the configuration. Okay. So see, if you talk about your devices, let me show you the ports for one router. Like this is one router. Okay, Cisco 202911. So there will be a dedicated port for it on which it will be mentioned that console. So the RJ45 connector here you will mention connected. Okay, like you can take this first device, just pass it on. This is what? This is a switch. On the back of this also you can find what? This kind of console port. On the port itself, it will be mentioned on the back side. Okay, port will be mentioned console. So this is where you will connect the console, right? And if you are looking for a router, this small device also you guys can check. Yeah, this first device, 1841. No, yeah, this one. Okay, so what the offline people are looking at is so Let me check if I have a clear image. See, this is what the offline people are looking at. So here also you can see there is a dedicated console port available. Okay. So again, this is where we will connect the RJ45 end, this end of the cable. And the other end, we will convert it into USB and I will connect it into my system. And then it is going to give me what? Access of the device. Now I can do the basic configuration of the device and later on I can use these ports FE01, FE00. Okay. I can use these ports to access it because on these ports I can configure IP address and all. Clear? Same thing. Now in that we have fast Ethernet port. Here we have GE, gigabit Ethernet. That means faster. Okay. So here we have like 3 ports. So mostly your Ethernet ports, they will be in this kind of yellow color. Okay. Here also you can see yellow color. Okay. And on the real device also you can see it will be in yellow color. And your console port will be in this kind of blue color. And the cable also mostly it will come in the same. And see, now these days we are also having what? Consoles that are directly coming with USB. Okay, directly from RJ45 to USB. Like one of the example, this one you can take. So nowadays we don't require what? The converters also. Directly the cable itself will come from RJ45 to this. Clear? So this cable, I believe I have it. You can just take out and check, no problem. Okay. So this is what? This is also console cable only. But here we do not require what? We do not require the converter. Okay. So this will eliminate the need of your converter. Directly USB interface you'll get. Okay. This is clear. Then next we have fiber cable. So fiber cable are what? These are cables that are carrying light signals. Okay. It's cables with a glass core. So these can carry the light signals, which will be much faster in speed. We know the speed of light, 3 into 10 raised to power 8 meter per second. That means almost 3 lakh kilometers per second. And also we know, now you guys already know, right? Circumference of Earth, 40,000 kilometers. That means your light signal in 1 second can travel around 7 to 8 times around the Earth. So that is the reason that your fiber optic cables, they can transmit large amount of data at very high speeds. Okay. So this technology is therefore widely used in the internet cables, that those cables we saw, right? The entire world is connected. So those are all fiber optic cables. Okay. And as compared to your traditional copper wires, all of you know, right? Engineers, copper, conductor, that means resistance. And when you have resistance, electricity starts degrading. Your voltage starts dropping. Correct? So with fiber cables, what will happen? That they are carrying light signal and they are carrying it in the glass core. So that means it will not degrade for a long time. Okay. So as compared to traditional copper wires, the fiber optic cables, they will be less bulky. That means less amount of weight will be there. They will be lighter, more flexible, and they can carry more data. Is that clear? So this is your introduction to the cables. Any doubts in the cable part? No? Online people? Now let's move on to the next part. Let me save this. All these paint files, you will find it in your drive. Okay. Every day I'll save these files into your drive. Now, next thing is about the IP address. We have to talk about IP address. So what is an address? Identity. Why it is used? To identify the node. So you can say it is an entity that is used to identify a node. Okay. Now, how many types of address? Two types. Directly IPv4v6. Mhm. Two types is logical and physical. Logical address and physical address. Okay, let's take an example here. WhatsApp group link. I have shared the access with everyone, right? Have you received the drive access? In the drive itself, you will find the link to join the WhatsApp group also. Okay, if you have visited the drive, see here. In your drive, now this is 5 p.m. So you will have a file with the name WhatsApp group invite link. So if you have received the access, make sure to join the group. Okay. You say you did not receive. Check. This is your email, right? You already have an access. Please check your emails, okay? I have shared with everyone, okay? So check your emails, and if you still didn't receive, just ping me later on, I'll provide. Okay. And if you do not find an email, sometimes happens that you will not find an email also. So what you will do, just open your Google Drive and go to this section shared with me. In this section, you will automatically find this folder B69 CCNA 24. Okay. Sometimes happens that you did not receive an email also. That is totally fine. Okay. So let's take an example here about the type of address. Let's say this is one university, university one. So in this university, how you can be identified? Name and enrollment number. Have I discussed this example? Then I will not discuss again. You already know, right? Physical entity, logical entity, right? Then no meaning of discussing it again. So I will directly start with logical and physical concept. So we know that our name is what? Physical entity, and enrollment number is what? Logical entity. So whenever you go from one network to another network, your IP address, your logical address will depend on your network. Okay, your network will assign what? IP address to you. But physical address, that is the address of the device, that is fixed with the device. So doesn't matter, I am carrying my laptop, like I'm connecting to Wi-Fi in office or home or some public place. It is still my laptop, it is still my device, same address. So physical addresses will not change. Okay. So about a logical address, what do we say? Okay, I think during the network components, I have discussed this. All right. So logical address. Now logical address means not fixed. And if it is not fixed, that means can be changed. Okay. Now, example of your logical address would be IP address. Example would be what? IP address. All right. And what about physical? Fixed. This is the type of address which is fixed. If it is fixed, that means cannot be changed. And when we say cannot be changed, basically we are talking about the BIA, burned in address. Burned in address. Okay. Now let me say like this, that also known as burnt in address, or in short, BIA. Okay. Example is what here? MAC address. Okay. This is clear. Okay. Sometimes you call it as a burned in address. Sometimes you call it as a hardware address also. Okay. Now let's talk first about the MAC address. So if we talk about the MAC address, what is the size of MAC address? MAC address is of 48 bits. So this is for 48 bits in size. Your MAC address is what? It is 48 bits in size. And yesterday we have seen how to define the MAC addresses. There are different formats. You can have hyphens, you can have colons, and you can have a dot also. Okay, and that will completely depend on the operating system. Okay. Okay. Now let's say if I take example of MAC address again, how do we check the MAC address? Get MAC is the command. So all of you have received access. Make sure to join the group. So see, this is how your MAC address is written. Okay. This MAC address is divided into two parts. Okay. The first 24 bits, this is different. And the last 24 bits, this is different. The first 24 bits, okay. So these 24 bits, these are known as OUI. And the last 24 bits, this is known as vendor specific. See, your MAC address is unique. Okay, so whatever is the MAC address of your device, no device in the entire world has the same MAC address. Okay, so it is unique. This is clear. Now, what is OUI? OUI stands for organizationally unique identifier. Okay. This is 24 bits in size. It is assigned by INA, the organization that is handling all your addressing, to the device manufacturer. So these first 24 bits, these will be assigned by INA. To whom? To the device manufacturer. So that your INA will make sure that no company in the world who is manufacturing devices, they should make the same MAC address. So they will assign different MAC address ranges to different companies. Okay. Now, what about the vendor specific part? The vendor specific part is selected by the manufacturer. Okay. It is also 24 bit in size. Okay. So it is the responsibility of your manufacturer that they will keep this thing unique. These 6 bits, they will keep it was as a unique. Okay. So vendor will not repeat this thing and INA will not repeat this thing. And this way your MAC address will be unique throughout the world. Is that clear? Okay. Clear about the MAC address? Okay. So how the MAC address is defined? This is the way in the Windows. Okay. Then here, if we use columns, this will be Linux. And if you use dot, that will be Cisco. This will be this is clear? Okay.
Excuse me, sir.
Noted?
Excuse me, sir.
Yes, please tell me.
Sir, can you explain the third point of OUI?
The third point. Yes, it is assigned by, see, INA. INA is an organization which stands for Internet Assigned Numbers Authority. This is an organization which is handling all the internet addressing schemes. Your IP address also they are handling. Okay. So whenever a device manufacturer wants to manufacture devices, so for MAC addresses, they will contact INA and INA will assign them with the first 24 bits. Okay. That means the first 24 bits INA will give them. So let's say I am asking INA for addresses. Okay. I am requesting INA for addresses. So one of the address, let's say for an example, INA will give me, let's say this is the part INA has given me. Now I can start making my devices and I can say my first device will be what? Like this. Then my next device will be what? Having the MAC address 2. The next device will be what? Having the MAC address 3. So like this, I can keep on making the devices. So I can change only this part. I can change only this much part. I cannot change more than this. Is that clear?
Yes, sir.
Manisha, is it clear?
Yeah, yes, sir. Thank you.
Okay. So about MAC address, physical address, it is clear. Now let's move on to logical address, which is your IP address. So how do you define IP address? How do you define IP address? In interview, you are asked, what is IP address? How will you answer? IP, Internet Protocol. Then they will say, we will call you. Sorry. But what is IP address? Question remains. Yes. What it will do, we know. What it is. No idea? All right. See, about IP address, at least 2 things we know. It is a logical type of address. Correct? And any address it is, it has to be unique. 2 categories we know. Third thing, what we know, that it will be used by to identify a node. 3 things we know. Use these 3 things and frame a definition. What you can say? It is a unique logical address that is used to identify a node in a network. Simple. Right? So I'm not saying you guys do not know, you know it. but how we answer it, that makes a lot of difference in the interview. Okay, doesn't matter how much technically strong you are, but if you are not able to explain, interviewer will think, okay, you don't know anything. Okay, and your package depends on it. Very important, right? So now in IP, we have two versions. One is IPv4, second one is IPv6. Now here sometimes when you tell, interviewer can confuse you that you have IPv4, IPv6, what about IPv5? This is your task for the day. This is your task for the day, that you have to check what happened to IPv5. Okay, so note it down, and tomorrow come after a research that what happened to IPv5. Okay, because sometimes it will happen that they will ask you, you will say your IP address, two versions, v4 and v6, and if they ask you what about v5, if you don't know, either you will say doesn't exist, or else you will say I don't know, and both are not a proper answer for a network engineer. Okay, so these are the two versions we have. Now let's differentiate between your v4 and v6. So this one is IPv4. This is IPv6. So let me write down here one example. This is an example for IPv4 address. Let's see 10.1. This is one IPv6 address. Now, in the looks, it looks very dangerous, right? When you look at IPv6, looks very complicated, but it is not at all complicated. Okay. When you'll study IPv6, you'll come to know that it is more easier than your v4. You don't have subnetting kind of tensions in this. Okay. No need to do subnetting, no need to calculate any subnet mask, nothing is there. Okay. So compared to v4, this is actually very simple. Okay. But we'll see that when we study about IPv6. So we are going to dedicate one session to the IPv6 itself, where we'll study from scratch to routing part. Okay. So one of the difference, you might say that, okay, your IPv4, what is the size? 32-bit, and IPv6, 120. Okay, here, tell me one thing. Let's say you want to take an internet connection. You want to take an internet connection at your home. And when you see the plans, they will say that, okay, we will give you 1 Gbps. They will give you what? 1 Gbps speed. So if they are giving you full speed, 1 Gbps, how much time it will take to download 1 GB file? 1 second. What do you think? Yes, connection and everything, your device, your connection, everything is 1 Gbps. 1 second. Think about it. Do you think we are paying for what we think? No. Hmm? No, full speed you are getting 1 Gbps. I'm saying you are getting 1 Gbps full speed. So how much time it will take? Then it should take 1 second, right? But now you'll know how they are playing with your mind. How the service providers, they are playing with your mind. How? Because when they are telling you that they will give you 1 Gbps speed, and what you are thinking, you will download 1 GB file. So there is a difference. What is the difference? They are talking about 1 GB small b, and when what you are thinking is 1 GB capital B. Difference between bit and byte. 1 byte equals to 8 bits. 1 byte equals to 8 bits. So that means when they are saying that, okay, we will give you how much? 1 Gbps. They will give you 1024 gigabits per second. If you convert it into bytes, what you're actually thinking, you will have to divide it with 8. When you divide it with 8, what do you get? It will take 8 seconds of time. But they will play us with this. They will play us with this. Because right now, okay, think we are technical. We will know about bit and byte difference. Think about common people. Now, common people, even they are getting this speed only. But earlier, when they were using mobile data and all, they were getting like 1 Mbps, 2 Mbps. So they will still think, okay, this is the fastest. Right? So this is how they are playing with our mind. You check with it. Okay, right now, let's say practical, I can show you. When I go here, and if I say, let's say I'll say what? Speed test. See, even the speed test will play us. See here, small b or capital B. Okay, so like right now it is showing what? 77, 78. So approx 80 we can understand that, okay, it is going to give us 80 Mbps of speed. But eventually when I'll try to download, I'll get 8 Mbps. Sorry, 10 Mbps. I'll get what? 10 Mbps. Why? 8 times lower. Because when we are talking about file sizes, they are in bytes. And when you're talking speed, it is bits. So this is how they will trick us. And we think, okay, now we will get full speed. Clear? So the smallest unit is what? Bit. Then after, directly byte. Do you have something else? There is something called as nibble. Nibble is there. How much byte? How many bits? 4 bits. Okay, then you have byte. Byte is 8 bits. So smallest is 1 bit. Then you have 1 nibble. Then you have 1 byte. Okay, and in the byte, it will always be capital B. And in the bits, they will give you small b. Then we have 1 kilobyte. Then it will, take this from 1024 byte. And then gigabyte, terabytes. Okay, that will keep on going. Like you can say 1 gigabyte. So that will be equals to 1024 kilobyte. Okay, same way, terabyte, 1024 gigabytes. Okay, like this, it will keep on going. This thing is clear. Now, one of the difference we got in size. The rest of the differences you have to just tell me just by looking at these two addresses, that what are the differences. So first of all, you can say that, okay, this is divided into 4 parts, your IPv4. So that means it is written in this form, 4 parts. Okay. So if 4 parts are having the size 32 bit, that means size of one part should be what? 8 bits. And the group of 8, we call it as a octet. So that means how many octets will be there? 4 octets will be there. In V4, we do have 4 octets. And each octet is size in, like each octet size is what? 8 bits. And for separation of these octets, what we are using? Dot. So I'll say here that you use what? Dot. Is used for octet separation. Same thing if we try in the IPv6. So we can say it is written in this form. 4, 5, 6, 7. So 128 bits divided into 8 parts. So divide 128 with 8. What will be the value of one part? It will be 16. Basic math. Group of 16 is what? Hexagon, not hexagon. It is hexagon. Okay, so how many hex states are there? 8 hex states. Okay, and these hex states, how do we separate them? With a colon. So you will say colon is used for hex state. Clear? Then other than that, you can talk about number of addresses. So the number of addresses in IPv4 is 2 power 32. Okay, no need to remember any exact number. You can say 2 power 32 addresses. And same thing, IPv6 is 128 bits. So 2 power 128 addresses. Because if somehow you remember IPv4 also, 4.29 billion, see here. If I say number of IPv4 addresses. So this is the number. So maybe somehow you will remember this. But when you go to IPv6, now how will you remember? Right? So better option is 2 power 128. Same thing, 2 power 32. Okay. This is clear. Then your IPv4, it is comparatively less secure than your IPv6. Okay, because your IPv4 does not have native IPsec support and IPv6 do have the support. So right now that security concern we do not need to worry about. Right now this much differences are totally fine. Okay. This is clear. So these are the differences between your V4 and V6. Any doubt? No? Remember these differences, I'll ask again when we are talking about IPv6. Okay, which will be at the end of CCNA. Okay. Noted? Okay. One more difference we can make here. Your IPv4, it uses all numbers. So that means here we are using decimal number system. And in IPv6, we use hexadecimal. Okay. This is clear. Now, what is number system? It was there in first year. I'm very sure. It was there in our first year. And first year is common for all branches. So you cannot say I'm from mechanical or civil. How many? First of all, what is number system? Good. Representation. Okay. Number system is a way of representing numbers. What it is? It is a way of representing numbers. Okay. How many number systems are there? How many number systems are there? More than I will explain, I will ask questions. This is something you should get habitually. Okay. Yes. 4. What are they? Binary, directly hexadecimal, octal, then decimal, then we have hexadecimal. Okay. Binary, how many digits? How many? 2. What are they? 0 and 1. In octal, 8. That is 0 to 7. In decimal, how many? 10. 0 to 9. In hexadecimal, how many? 15. Hexadecimal, hexa means 6. Decimal means, deci means 10. So 10 plus 6, 16. What are they? 0 to 15? Or ABC? A. Okay, why it is A, B, C, D, E, and F? Why not again 10, 11, 12, 13, 14, 15? Why it is A, B, C, D, E, F? Why not 10, 11, 12, 13, 14, 15? Which number? So what? If I'm writing 0 and if I'm writing 10, if I'm writing 1, if I'm writing 10, there's a difference, right? That means if you are writing somebody 1 rupee check and if you're writing 10 rupee check, so is the bank going to write 1 and 0? So they will credit 1 rupees and then 0 rupees in the account? No, right? Then, yeah, if you're writing this far, that makes a difference. But if I'm writing like this, shouldn't make a difference. And when I'm saying 10, this is what we are meaning, right? So why didn't I use here, 10, 11, 12, 13, 14, 15? Why not like this? So see, they could have written it, okay? But the problem is when you convert hexadecimal into binary. When you convert hexadecimal into binary, so you have to take one hexadecimal bit. So if you write 10 instead of A, it will become 2 digits. For each digit, you will calculate the binary. So it will be calculated for 1 and 0 rather than calculated for 10. So during hexadecimal to binary conversion, this would be a problem because we understand hexadecimal totally no problem. System will understand what? Binary. So to prevent that confusion, okay, they use E to F. Now here the value of A is, guys, there is some, oops, guys, there's some issue. Am I audible? I don't know, internet also gonna get. Yes, it is gone. Our internet will take some time. Online people, can you hear me?
Yes, sir.
Yes, sir.
So there are some power problems and got internet disconnected. Might be right now you are facing some internet issue. Like might be the voice is not proper. That can happen. Again, got disconnected. Internet is unstable. Okay, let's do one thing. We'll complete this this number system and then furthermore we'll continue tomorrow. Okay. Otherwise, you will get 2 different recordings for 10 minutes also. Okay. So here, the value of A is what? Now fine. So value of A is 10, value of B is 11, value of C is 12, value of D is 40, value of E is 15, and value of F is Oh, sorry. 13, 49, 15. Yeah, I was like, how come it is 16? Okay. So this is how it is. Clear? So these are your number systems. So furthermore, we'll start tomorrow. For tomorrow, what you have to practice today? You will practice binary to decimal conversion. I guess you already know. Binary to decimal conversion as well as decimal to binary conversion. Okay, this is very important for subnetting part, which will be coming for us. So today you guys check this, and one task I have given you for IPv distinguisher. And see, whatever these things, whatever the things I'm giving as a task, and whatever the things I'm telling you about interview perspective. Okay, so note them down. They will be really helpful in the interview. Okay. All right then, let's wind up today, and tomorrow we'll continue with this part. Okay. Online people, any doubt in today's part?
No, sir.
All right. So we'll continue, guys, today. I mean tomorrow. Okay.
Okay. Thank you.
All right, guys. Have a good day. Bye bye.